So this is the 2016 Leaving Cert Ordinary Level Paper 1, and we're looking at question number 5. The first 5 numbers in a pattern of numbers are given in the table below. So U1 is the first term is 13, U2 15, and so on. Part A1 says follow the pattern in the table above to write the next 3 numbers into the table. Okay, so if we have a look here, what's happening? From this term to that term, there's a jump of 2. And then from 15 to 19, the jump of 4. From 19 to 25, the jump of 6. From 25 to 33, there's a jump of 8. So we can see there as we go down that the jumps are getting bigger by 2 each time. So the next jump would be plus 10. So 33 plus 10 is 43. The next jump would be plus 12 if we follow the pattern. 43 plus 12 is 55. And the final jump then would be a jump of 14. So 55 plus 14 is 69. So there we have the 3 missing terms, U6, U7 and U8. Okay, so part 2 says use the data in the table to show that the pattern is quadratic. Okay, so if we go back, if it's quadratic, the second difference will be a constant. So I'm going to do this in red. So if we have a look, the second difference would be what's the jump from this jump here. So from 2 to 4 there's a jump of 2. And from 4 to 6 there's a jump of 2. From 6 to 8 a jump of 2. From 8 to 10 a jump of 2. Plus 2. Plus 2. So because the second difference, this was our first difference in blue, and the second difference now is a constant, it's 2, so that means that it is quadratic. So we can say second difference is a constant. So that implies quadratic function, or quadratic sequence. Okay, so part B says un is equal to n squared plus bn plus c. So un is the general term for this sequence that we've been looking at, is n squared plus bn plus c, where b and c are elements of the set of integers z, and we're asked to find the value of b and c. Okay, well, we need to have a look at what we do know. So we know that u1 is 13. So u1 is 13. Now if they tell us that, and we also know that u2 is 15, so we're going to take 2 values. It doesn't matter what 2 you take. So u1 is 13, u2 is 15. So we know the general term un is equal to n squared plus bn plus c. And we're looking for b and c. Well, u1 then, if un is n squared plus bn plus c, well then u1 will be 1 squared plus b times 1 plus c. And we know that u1 is 13. So when we tidy that up, we get 1 squared is 1, plus b times 1 is b, plus c is equal to 13. And if we bring this 1 over here, it becomes a negative 1. So we get b plus c is equal to 12. So that's one equation there with 2 unknowns, b and c. So the next thing we're going to look at now is u2 is equal to 15. So u2 would be, we're substituting the 2 now in for the n, so it would be 2 squared plus b times 2 plus c, and we know that u2 is equal to 15. So working a little bit on this here, we get 2 squared is 4, plus b times 2 is 2b, plus c is equal to 15. So if we bring this 4 over to the other side, it becomes a negative, and we get 2b plus c is equal to 11. So that's 2b plus c is 11, and that's our second equation there. Our second equation with two unknowns. So if we now we can solve both of these two equations simultaneously. So if we have 2b plus c is 11, and underneath we write b plus c is 12. So we have plus c here and plus c there. If we want to eliminate them, we're going to subtract. So we're going to subtract 2b minus b, which is b. C minus c, they cancel, disappear. And then 11 minus 12 is minus 1. So we have b is equal to minus 1. And then we're going to substitute that value into one of the other two equations. So I'm just going to take the easy one here. B plus c is 12. Well, I just figured that b is minus 1, so that becomes minus 1 plus c is 12. Okay, well then I bring this minus 1 over here, it becomes a positive 1. So c is equal to 13. So c is 13, and b is negative 1, and they're my two answers. Okay, so finally part C says, the table below shows the first 5 terms of an arithmetic sequence. Find an expression for Tn, the nth term of the sequence. Then hence or otherwise find the value of T30, the 30th term of the sequence. So here we have the first 5 terms, and we can see here as we go down we're going up in 2's. Plus 2, plus 2, plus 2, plus 2. So it is arithmetic, they told us that in the question. Arithmetic is when it goes up or down by the same amount. So we're looking for Tn. Now from the tables book we have a formula. Tn is equal to a plus n minus 1 times d. A is the first term, so this will be a will be T1, which is 12, and d is the difference as we go through the sequence. So the difference then is plus 2. So we're just going to sub them in, those values in here. So Tn will be equal to a, which is 12, plus n minus 1 multiplied by d, and our d is 2. So n we're going to leave alone because we want Tn, we're looking for the nth term, so n will be part of that. So Tn, that becomes 12. This 2 gets multiplied by each thing in the brackets here. So 2 by n is 2n, and 2 times minus 1 is minus 2. So when we tidy this up, we have 12 minus 2, that becomes 10, plus the 2n. So that's our Tn. Tn is equal to 10 plus 2n. So the last part then, they said hence or otherwise find T30. Well, I'm going to, hence generally means using what you just found. So I've just found that Tn is 10 plus 2n, so T30 will be equal to 10 plus twice 30 instead of twice n. And that's equal to 10 plus 60, which is 70. And that's the end of the question.